Okay, and then let us start. And if you recall, last class, we started discussing linked list. Okay, so this is the simplest case of a linked data structure. And a linked list, its basic building component is a node. And a node has two parts, the data parts and the next part. Okay, so this is considered a node. And for a linked list, there's a number of nodes chained together as a linked together. And yesterday we also discussed for linked list data structure, the operations that normally we need to think about is insert. So for linked list can insert anywhere. And we discussed different scenarios for insert operation. Okay, we can also remove. Let's also remove anywhere. And we can also do traversing. So traversing it means node by node visit. Okay, so generally speaking, very important operation regarding linked list are those three operations. Okay. So then next, let's see how are we going to, so conceptually, we already understand linked list. So now let's see, how do we create a linked list class? So over here, we create our linked list. This is a generic one. We already learned generic class and generic method. So here we want to create a generic linked list. So we parameterized, it's T, but this T is bounded. Bounded by what? The comparable interface. Okay, so that just means T can be any concrete class which implements the comparable interface. Okay, so that's what it means. Okay. Okay, so anyway, so that's regarding linked list, our linked list class. And then if you recall last class, we also discussed the node, basic building unit node, and node over here, we put it as an inner class of the linked list. Okay, and we also define it as a static class. Okay, static class. Because for static class, over here is you don't need an object to have a node. So it can be independent of the linked list. Okay, so that's the point here. Okay, and for node, we have two parts, and this is a generic node. Okay, it has the data part, it's generic, and its next part, the type is node, also generic node. Okay, and when we create node, so we just assign data next to the respective field. So this is regarding the node class. Okay, and then for a linked list, so in our last class, we discussed the linked list. So this is a linked list. Suppose each node holds some numbers. Is it? And for this linked list, if we know the first node, last class we also explained this. So once we know the first node, basically we know the complete list, because we can always access the other nodes through the first nodes next. And once you get second, you can, through second nodes next, you can get to the third. Is it? So that's why when we implement linked list, we just need that instance variable, a single one. The first node, the type is a node. Okay. So for linked list implementation, we just need this single instance variable, okay, first. And then next, let's see. The first is about a constructor. So this constructor is create an empty one. So for an empty, that just means you set the first to a null. It's an empty one, is it? So first, just a null value. Okay, and normally for any data structure, we also want to know if it is empty, is it? So how can we check empty? Then we check if the first node is the null value, is it? If this the same, okay. So that's regarding this two method, not a lot of new things. And then the toString. So toString is we want to get out all of the linked list contents, is it? So over here, suppose we have that linked list. So we have 100, 200, 300, 400, and 500, is it? And here we know the first node. Okay, so how do I output all of this? 100, 200, 300, 400, 500, is it? So here it involves the concept of traversing. So traversing is to do node by node visit. Okay. And then we cannot use the first dot next, multiple dot next. That will not be efficient, is it? So last class, we also explained. Suppose we set some temporary variable. And we call it a cursor. And the type should also be a node. Is it? So you make this node, you set it to first. Initialize it to first. Is it? And then you can get its data part. And suppose we want to output 100 comma and space, then 200 something. Then we just append all this information to a string builder variable. Okay. After that, for the second iteration, how do I advance? So I can just set cursor equals cursors next. So in this case, we advance the cursor, is it? This is cursor's next, and you set a cursor to it. So then it's moved to the second node. Then you can get the second node's data, is it? And after you finish this, you can do this again, reset cursors next to cursor, is it? Then you move to the third one, is it? And then you move to the fourth one and move to the fifth one, is it? For each of it, its cursor equals cursor's next. That's it. And when should we terminate? It's when cursor is not when cursor reaches the end, no, is it? Then that's the end of the loop. That's a termination, is it? So we can get, so the way to do the node by node visiting, the traversing, is to use cursor equals cursor dot next. Okay. And then during the loop, then we can always retrieve the information, okay? And the last step here is convert the string builder to strings, and then we return the string result. Okay, so this is regarding how do we do traversing, okay? And what is the next one is to discuss the insert operation. And here we assume insert in ascending order. Okay, just for simple case, okay. So there are a number of scenarios we needed to think about it. So the very first for the insert work is, so scenario one, case one, is an empty one. Empty one, how we identify it's if the first is no, is it? Then we want to do what? So here is your item. So you need to create this new node. That's what this part means. So you do new node, item, and its next is a node. But then you need to assign it to first. Assign it to first. Okay, so this is when the list is empty. Okay, list is empty, case one. And then the second scenario, let's think about it. Suppose we already have the existing one as it. We have 100, 200, 300, 400, and 500. Here is our first. Is it? And suppose the item is 50. So if you want to add 50, you first need to create this new node. And the next, where you should connect. So you should connect to next. So that's why when you call the new node, you provide first as its next. But this is not, you haven't updated the linked list. You need to then reset the first to new node, update the first node. Okay, so this is to insert at the beginning, okay. Okay, and then the last case is we can insert in the middle or at back. Okay, so here the first step is we need to identify. So here's 100, 200, 300, 400, 500. Suppose we want to insert 350. So 350, we know it should be insert between 300 to 400. So the very first thing we need to identify is we needed to find the 300, need to insert after 300. So we need to identify this node 300. So how do we do it? So we make a cursor. Start at first. That's it. And of course, if it's already reached the null value, that means it reaches the end. That's it. Otherwise, how are we going to compare? So we compare its next data. Okay, so in this case, it's 200. Is it? Compare it with the item. If this value is still less than that one, then we are going to advance it. Okay, so in this case, 200 is less than 350. So then your cursor moved. Is it? Advanced to 200. And then next iteration, you compare 300 with 350. It's still less than. So you advance it to 300. And when you compare 300 with the next, so it's 400 with 350. So this condition is not true. So the loop is going to be stopped. So that's how you identify this cursor. So we know it's going to insert after 300. Is it? So then how do we create this new node? So we first need to create this new node. This new node, it's next. It's going to point to cursor's next. Cursor next 400. Is it? And then you're going to reassign cursor's next to 350. Is it? Then in this case, you have this 350 insert between 300 and 400. Okay, so that's this case is going to work. Then let's see if this code also work for 550. Is it? For 550, then when we loop, it's loop. So this will be the termination condition. Is it? So here is our cursor. Cursor's next is null. So you stop here. So here is cursor. Okay. We identify cursor, then we create this new node. Cursor's next is null. So you need to reset the 550's next to null. Then you set cursor's next to 550. So it still applies. So this part of code apply to both case, insert in the middle and also at the back. Okay. Okay, so that's regarding insert in the middle and at the back. And then next, let's take a look, how do we remove an item? Okay, so over here, same thing, the number of scenarios we need to think about. If the list itself is empty, then definitely, that's why we just throw exception, some runtime exception, etc. And the first case is you remove front node. How do we do that? Etc. So that's the first node's information. This is the item you want to remove if both are the same. Is it? So then how are we going to update it? We have 100, 200, 300, 400, and 500. Then here is the first node. Is it? So suppose you want to remove 100. Is it? To remove 100, so basically over here, so you just reset. So then this is going to be off the list. Is it? So you just reset first equals first next. So first point to 200. Okay. So this is a case you remove the front node. And then next, let's see some other cases. Okay. So assuming here, let's go back to this list visually to see how did we do it. So we have 100, 200, 300, 400, and 500. Okay, suppose we want to remove 400. Is it? So how do we do it? Okay, remove 400, then it involves, you get rid of it. And also you need to reconnect 300 to 500. Is it? So this is the node. First, you need to identify its location. So we can use a cursor to find the item, the node, where it is it? But at the same time, it also involves, you need to connect its previous one. So how can we know who is the previous one if we just have cursor? There is no way, is it? So that's why over here, we also have a variable, we call it previous one. So this one will track the previous node that's visited. So keep tracking of this one also. Okay, so then in this case, how are we going to do it? Let's get rid of this so that it's more clear. Okay, then in this case, what we do, so here is the first. So we start our cursor at first. And this previous is a null value. Okay, then how can we identify 400? So that just means when its data is equal to the item, is it? So that's where you can identify cursor. Okay, and of course, if you say, I want to remove 600, 600 is not on the list. So then you also need to guarantee it's after the null, you should stop your loop. Is it? Okay, then how do we keep track of the previous one? Then let's see. Each time when we advance, so this is the advance, and you want to remember the previous one, is it? So how do we, so you can let previous point to the current one first, and then you advance this to the next. Okay, so over here, this concept, we can call it pair advancing. You advance two cursor together, is it? Then within the next loop, this previous is going to point 200. And this cursor will point to 300, is it? So each time when you do it, then it will point to 300, and this is going to point to 400. So each time you do pair advancing, you advance a pair, is it? And then the next one, then it's going to be advanced to 400, and this is going to be advanced to 500, is it? Oh, sorry, so in this case, 400. So we advance, we find the 400, so cursor is here, and previous is 300, is it? We located. So after we locate, then how are we going to remove? So you just set the previous nodes next to cursors next, then this one will be off the linked list. Is it? Though it's still point to 5, but it's not connected with the list. So this one will be garbage collected. That will be garbage collected. So that's how we delete the node. Okay, this also applies to the last one. Is it? Suppose if you want to remove 500, if you want to remove previous is 400, is it? So previous set to next, so there's a point to now. So 500 will also be remove. So it applies to both cases for this remove operation. Okay. So that's how, so when we do remove, just keep in mind, this is a key point. We do pair advancing. Okay, a key point. Okay, so generally speaking, so that's all regarding our linked list, okay, concept. And then let's take a look, how are we going to use it? So once we have that linked list, the first thing is we create a string linked list. And string implements comparable interface. So that's why we can do this, okay? So that is fine. So initially it is empty, it should be true. Then you just insert. And here we are in random order. We can take a look what the result is. Is it? Then we also insert this one. Is it? And we output it. And then we also call remove to remove someone. And we can also check if the result is removed, okay? So when we try to use it, it's pretty straightforward. So let's just take a look at the result first. And first is empty. We insert each individual one, but we can see it's rearranged in ascending order. Is it? And then we insert the new one. So it's also insert after E. Is it? Then we remove E, so you can see it's being removed. Okay. And then what next? We create an integer. Integer also implements comparable, so that's why it will work here. Okay. And then we just insert some values, etc. And then after that, we call another insert. And then we also do remove. Is it? So let's see. So it's arranged in ascending order. Is it? And then we insert another 155. And then we also remove 30. So it's gone. Is it? So it's pretty straightforward in this case. But over here, we can see the advantage for linked list is it supports insert and remove anywhere. Is it? If you have a lot of insert remove anywhere kind of operation, it's recommended to use a linked list. It's more efficient. If you want to use array, it involves heavy shifting work. Is it? So not that convenient. Okay. Okay, so this is the first version of our implementation regarding linked list. And then let's see. The second one. The second one is this one. Okay, it's called Java linked list EX2. Okay. So there are a couple of 4 files here totally. We have a clonable linked list driver. We also have a car .java file. Okay. So first, let's take a look at the clonable. Okay. So we also here define an interface. And this interface is from the clonable, sub-interface of clonable. So we just gave a abstract method called clone, okay? So this interface itself is pretty straightforward, okay? And then next, let's see. This time for this linked list we define, it also a generic, but it's bounded generic type. So the bounded type is with the clonable, okay. And this linked list itself also implements iterable. So that means this linked list is going to support for each loop. And you need to override that iterator method. Okay, because that's the method for iterable. Okay. Okay, so that's regarding this linked list. And for this linked list as a node, okay. And for the node part, it's similar as what we saw before. Is it as data next, nothing new here. And for the linked list, we have only a single instance variable called first. Okay, so also nothing new here. And for the constructor, nothing new, empty, not new. And for the insert method, this time we define it different. We define it to insert a new item after some specified item. Okay, so that's what we are going, we call it insert after. Okay, insert after. So then there are multiple scenarios, the same thing. If the link is empty, then you just directly do create a new node and assign it to first. Okay, so that's this case. The second case is you need to identify where the item is. Is it where the item is? And also maybe the item is not on the list. Then you are going to insert at the very end. Is it? So that's how this while loop work. Okay, and because over here it involves insert after the item. Is it after the item? So what over here, we also have a precursor. So just like what the remove did, we also keep track of the the one before it. Okay, the one before. And the case why we do this is if your loop reaches the end of the linked list, because then cursor is null, is it? So then you lose track. If you want just use the cursor, where are we going to insert? Is it? So that's why over here we use a precursor. Okay, so then here same thing, you do pair advancing. Okay, do pair advancing. So if cursor is not the null, so that means, so cursor is somewhere in the middle. Then it's pretty simple, is it? Then you just create that new node. That new node's next should be cursor's next. And then this new node should be assigned to cursor's next. Okay, so that's when it's in the middle. And if it's the end, so when cursor is null, is it? Then here is a precursor. Precursor is here, is it? So then what you can do is you create a new node here. Is it create a new node? And then you set the precursors next to this new node. Okay, so this is how this insert after works. And for the remove, I don't think there is any difference, okay? And there is also another method called contains. So this is kind of like the search method, okay? We will come back later to explain because it's used for each loop. And then what to the next one is, this one kind of serves like the indexing operation. Is it? So based on the number of the location, is it? You want to retrieve the item, okay? And of course, it's empty, then something is wrong, is it? Then otherwise, we set our cursor. So whenever we do the loop, we use the cursor. As I set the cursor to the start location, okay? Then it's based on where it is. So we loop the number of iterations. Is it? If cursor is already null, that means it's already beyond the index. Is it? The number of nodes within the linked list. So that's why you need to throw exception. Otherwise, you can also always advance the cursor. Is it? Always advance the cursor. Okay, after we advance the cursor, we find where the item is. Then we want to return its information. Is it? But over here, because the data part, should be private. Is it? So it should be encapsulated. So shouldn't expose. Is it? Shouldn't expose. So if you just return it, suppose if it is an employee or account, then third party can get your account. Is it? It's not protected anymore. So we don't want that to happen. Is it? So that's why over here, where is that? Okay, here. That's why over here, we call it clone. We return a deep copy so that the original one is still protected. Because for the clone one, if you want to do any modification, it won't impact the original one. Is it? So that's why, if you recall, we said T extends from that T clonable interface. Is it? And because of this clone method, okay. So anyway, so over here for this indexing operation, it returns deep copy of an item. Okay, don't return the shallow copy. Okay, that's violate encapsulation. And for toString, later on we will come back to explain. Okay, and here there's another one is the equals method. So for this equal, that means you want to compare two linked lists. So you have one linked list. So 100, 200, 300, 400, 500, is it? And you have another one. It is at a different location, the 100, 200, 300, 400, and 500, is it? And it's at a different location. You want to see, suppose, the first one is object itself, and this is the other. Okay, then you want to see if these two are the same, the equals. Is it? And it says if other is null, okay, and if yourself is also null, it doesn't exist, then you cannot compare, call the equals. This that. That's why whenever you do comparison, that means the object already exists. So that's why over here to return false. Okay, so if object does exist, then of course you also need to compare if both are the same class. Okay, if not the same class, you return false. Okay, if both are the same class, then we are going to do one by one comparison here. Okay, and over here we also name this one as second. That's what over here we did. Okay, and then we set up the cursor second first. Okay, second first. And here is the object itself. Okay, so anyway, here it uses for each loop. Okay, use for each loop. With the for each loop, and if cursor is null, and because it's still within the loop, so that means both are not the same. Because the other one still have nodes, but this one doesn't have nodes anymore. So that's why it's return false. Otherwise, what you need to compare is, because this will get to the information part. Okay, so then you are going to compare the information part with the cursor's data. Cursor's data is this. So over here, you compare the data part. Is it? So if both are the same, then you let your cursor advance to the next. Is it? And then over here, that's the for. Reach to the next one, then you can compare. Okay. Then if cursor is not a null, so that means, so cursor is not null, that means the second one has more items. Is it? You maybe have 600, but this one already reached there, but you have more. So then you still need to return false. Otherwise, if you always with the each iteration of the loop, then you return true. Okay, so that's how we do the comparison with two linked lists. You need to do one by one check. One by one check. Okay, and you make sure the data part are the same. You call it equals. So here, each linked list is at its own location, and the data part is also the deep copy, basically, kind of. Okay, at a different location. Okay, but they own the same contents. Okay, so that's regarding the equals method. Okay, and what the next one did is we copy the list. So the copy list, the return type is a linked list. And over here, it's not object itself, it's a deep copy. Okay, so how do we do the deep copy? So that's why here, you first need to create a new linked list. Okay, you create a new linked list. So over here, we have 100, we have 200, then we have 300, we have 400, we have 500. This is the object itself. Is it? Okay, the cursor set to the first node. So here is the first node. Okay, first node. And then over here, we create a new linked list. So that's empty. So if first is a null, then your copy should also be null. Is it? Otherwise, then you have the copy. The copy is first. The first needed to get the information. Is it? So you needed to use that 100 to create a new node. Is it? So that's how this part. And it's also a deep copy. So the clone, not the object itself. So that's how here you call the clone. Okay, to create a deep copy. Okay, create a deep copy. And this is a new node. Is it? Then you assign it to the first. To its first. So this is the copy first. You let it point to here. Okay, and its next is null. Okay, and then the cursor going to move to the next. So cursor point to the second one. Okay, point to the second one. And over here, we also have a temporary cursor. Temporary cursor is going to remember the new linked list's most current node. Okay, so this is called TMP cursor. Now it's also pointing to that node you just created. Okay, so then for this one, because now your cursor moved to second, is it? Move to second. So you need to have a new node created. So we create a new node, the 200. So that's cursor's data clone part. It's going to happen. Is it? Create 200. Okay, create 200, and then you also need to connect both together. Is it? So this is just its next. Is it? So that's how this is going to be assigned to next. But after that, then you also need to move this temp cursor to the second node. You also need to advance it. So within the loop, you do advance for node, for cursor. You also do advance for the temp cursor. Okay, so you do both advancing. Okay, and the same thing, you do the first, you first create that new node, a deep copy. Then you need to advance this temp cursor to the third one. So we keep doing like this. Okay, and finally, then you can return this new one. So this new one is going to be created at a different location, and each node will also have deep copy of the contents from each node. Okay, so this is regarding the copy list, how it works. And we run out of time. We just have 1 more minute and we cannot